All right, so this is section 8.1. Remember, this is not on your test, it's on test 2. So your test 1 stops up to what we did last class period. And remember, at the beginning of class, I said the absolute value with the less than, we did it on page 13. That's on your test, right? Okay. So is the absolute greater than on your test? No. Right. Okay, so this is where we start talking about systems of equations. And one of the handouts you picked up was on section 8.1. Up there. And so in 8.1, they tell you the steps to solving a system by substitution and by the addition method. So we're going to do the substitution first. So we're going to solve a system by substitution. Okay, by substitution. So 8.1 is not up there?
The worksheets are up there, but not the notes.
Okay. All right. Maybe I didn't print them. Maybe I forgot to print them. I'll print them for next time. So don't print them out there. There's quite a few pages. But just listen to the words, and then what you may want to do is when you look at the videos, because when I post this, I'll go ahead and post the notes with it, although it's already on Canvas. 8.1 notes are already on Canvas. Just listen to the words. Okay. All right. So let's look at this example. So 8.1 it's fairly easy. Solving a system is fairly easy. On the final, most students can get those. All right, so let's look at this example. Even before we do substitution, let me do this first. So here's a system. So when we talk about system, we're going to use this little brace here to indicate we're dealing with a system. And so let's say one of my equations is this: x plus 3y equal 11, and then x minus 5y equal negative 13. So that's my system. So this system has how many equations? 2. You can have a system with 3 equations, 4 equations, so on. In here, though, we're only going to be dealing with 2 equations. And the question is this. So the question is negative 3. Let me do this. Negative 2, 6. Okay, is 17 negative 2 a solution to this system? That's the question. Is 17 negative 2, is the point 17 negative 2 a solution to the system? So is this a solution? All right, so in 8.1, I asked you to look at that video, and you note that a solution to a system is where the graphs intersect, correct? So that point is on both graphs, correct? Where they intersect, they're on both graphs. So that point has to satisfy both equations. So to determine if that point is a solution to the system, it has to satisfy both equations. So 17 negative 2 has to be a solution to both equations. All right, so you just plug in and check. So when we do these, it's a good idea because you could make some algebraic errors along the way. So it's always a good idea to check your solution, make sure it's correct. Because again, it's very easy if you're not careful to make errors. So let's do the first one. So x plus 3y is equal to 11. So wherever we see an x, what do I plug in? Because that's your x and that's your what? What? So I get 17 plus 3 times y. What's y? And I want to see, is that equal to 11? So that's 17 plus a what? Negative 6? Is that equal to 11? Yes. So can I automatically say that that point is a solution to the system? No.
Because both have to be a solution.
It has to be a solution to both of them, so I got to check the other one. So the other one, have x minus 5y is equal to negative 13. So x, I'm saying, is 17 minus 5 times y is negative 2. And the question is that equal to negative 13? Well, that's going to be 17 plus 10, right? Okay. 17 plus 10 is 27, and that's not what this is. So therefore, -2 is not a solution to the system. Okay. What about this one? Is 2, 3, that's a 3, a solution? So is 2, 3 a solution? Well, wherever we see an x, what do you plug in? Wherever we see a y, you plug in 3. And so you got to check each equation, though. So let's do the first one. X plus 3y is equal to 11. So what's x? Plus 3 times y, what's y? So the question is that equal to 11? 2 plus 9, is that equal to 11? Yes. All right. So 2, 3 is a solution to the first equation, but we got to make sure it's also a solution to the second. So x minus 5y equals negative 13. Okay, again, what's x? Minus 5 times 3. And I want to see that's equal to a negative 13. So 2 minus 15 is what? So that works. So therefore, 2, 3, the point 2, 3 is a what? Solution. And it's a solution because it satisfies both equations. Now, if I were to graph this, what would the point 2, 3 indicate if I were to graph these two linear equations? That's where they would intersect. They would intersect at the point 2, 3. Okay? So that part, that concept was in that video I asked you to look at. Okay, so that's what you're finding. When you find a solution, you're finding the point that makes both equations true at the same time. So now let's look at substitution. So we're going to solve the system by substitution. Now, there are going to be some problems with my math lab where it's going to say just solve. So if you just say just solve, you can use any method you want to that we discussed. So either substitution or the addition method. But if I ask you to use substitution, usually this is the idea. So let's look at this one. Let's do number 1. X plus 3y equal 8. Y equals 2x minus 9. All right, so there's my system. Now you see how one of the equations, the variable is already by itself? Whenever you see that, and I'm talking about the second one, right? What variable is by itself in the second one? Y. Whenever you see that, then the best method to use is substitution. So if the system already has a variable by itself, if one of the equations is already a variable by itself, then the method to use would be substitution.
Okay, a second ago you said that what we just did was substitution, but that wasn't. That was.
No, I erased it.
Okay.
I erased it.
No, you just said it. I was listening to your words.
Well, I did what now?
You said it, but I heard you were like, okay, that's substitution. And I was like, oh crap, so I wrote it. But it's not.
I said this was substitution?
Yeah, you did.
Okay, sorry.
It's not, though. It's by itself.
No, I'm just checking to see if a point is a solution. Now I'm going to substitute, maybe I said that. I'm going to substitute in place of x, I'm going to substitute what? 2, and in place of y, I'm going to substitute what? 3. Maybe I use that word.
The system already has a variable by itself, it's best to use
Substitution. Yes. So since the second equation, the y is already by itself, we use substitution. All right. So listen to the steps. You don't have the steps in front of you, but go back and look at the notes that went with it. All right. So step one. Step one would be to take one of these equations and get the variable by itself. Take one of the equations and get the variable by itself. All right. Well, that one's already been done for you. Step one has already been done for you because which equation already has the variable by itself? That one. But that will be step one. So we're going to do one where the variable is not by itself. So you would have to do step one. So then here I'm just going to say y equal 2x minus 9. So that's what I'm going to use. So that's the equation in step one that I'm going to use. All right. So take one of the equations. So which equation did I take? The second one. And I got the variable by itself, although it already was by itself. So I'm taking the second equation. And again, the variable by itself, although it's already done for me. Okay, now listen carefully to step two. Step two. Substitute this equation, y equal 2x minus 9, into the other equation. So substitute y equal 2x minus 9 into the other equation. So in other words, I'm going to take this right here, and I'm going to put into the other equation. But remember, what variable is by itself? So in place of y, I'm going to substitute this expression here, and it sometimes helps if you underline that expression to the right of the variable you got by itself. So you see I got y equals 2x minus 9. So what did I underline? 2x minus 9. So in place of y in the other equation, I'm going to plug in what? Because that's what I'm saying y equals, right? What does y equal? 2x minus 9. So now it's going to look like this. So when I substitute, it's going to look like this. X plus 3 times y. But what is y now? But remember, I got to use parentheses. Make sure you see y. Because both terms, 2x minus 9, has to be multiplied by what? 3. So hence parentheses. And that's going to equal what? 8. All right, so let's go back again. So step one is to take one of these equations and get the variable by itself. Well, this one's the easiest one to use because it was already by itself. Now I'm going to ask you this. Could someone have chosen the first equation?
Yeah.
Yes. What would be the easiest to get by itself? X. Very good. All right. So the easiest one to always get by itself is the one that has what kind of coefficient of x? 1. I would not get y by itself in the first one because at some point you'd have to divide by what? And you'd end up with fractions. You don't want to deal with fractions. 8/3, 1/3, okay? All right, so the idea is when substitution to get the variable by itself, use the variable where the coefficient is already a 1. Okay, so again, you could have used the first equation, got x by itself, but it's easier to use the second because y is already by itself. So then I take this expression here and I plug it into the other equation in place of y. And this is what I get. So now notice I have a linear equation with just x's in it. See that? Do you see any y's in here? No. So you had something like this in Math 92 3 semesters ago, or Math 94, or now it's called either Math 97. I think it's Math 97, right? What's the next step? Yeah, you had this kind of equation the last 3 semesters. Math 99, Math 98, Math 97. Distribute. So x plus 6x minus 27 equal 8. So step 3, by the way, so this right here is step 2. This right here is step 3. So step 3 is to solve for the variable. So step 3 is to solve. So this is step 2, and now I'm doing step 3. And when I say solve for the variable, which variable am I talking about? X. Solve for X. So this is step 3. Okay, what's the next step? So I get 7x minus 27 equal 8. What's the next step? 27 to both sides. Combine like terms. I get 7x is equal to 33, 35. Okay. All right. Divide both sides by 7. What is x? 5. So remember, when you solve a system, you think about where the graphs intersect, and they intersect at a point, correct? And that point was an ordered pair, x comma y. So I found the solution to which coordinate of my point? The x. So far my solution, when you list it as an ordered pair, remember ordered pair xy, what goes here? 5. So there's my x coordinate of my solution. All right, so I found the x. Now I got to find the y. The y. So it'll be step 4. Okay, listen to this. Step 4. Your book uses the word back substitute. So we're going to back substitute. I'm going to back substitute. So meaning this. So I now know what x is, correct? So when I back substitute, I'm going to take x and I'm going to go back. I'm going to go here. I'm going to go back and wherever I see an x in one of these equations, doesn't matter which one, wherever I see an x, I'm going to plug in what? 5 and then get y by itself. Okay, now, most students, though, will go to the equation that's in step 1, where the variable that they're looking for is now by itself. But it didn't matter here because isn't this right here this? Yeah. It didn't matter. So, but most students will go to step 1, and you're going to see what I'm talking about in a little while. So back substitute. So here's what we're going to do. We're going to substitute x equal 5, this one here, into the equation we got in step 1. What was the equation we got in step 1? Yeah. Now you got to be careful. See, if you use the one that's in step 1, you better make sure that you went from here to here correctly, okay? All right. So in place of x, what do I plug in?
5.
Plug in 5. So in other words, I'm going to substitute in place of x, I'm going to substitute 5. So I get y equal 2 times x. What's x? Minus 5. Oh, I'm sorry. It's 9? Yeah, okay. All right, 9. Now, you see how I made a mistake here? So you would have gotten 5. If I said 5, that would have been what, 5? And you said I made a mistake, right? So what should you always do? Check your solution, because you can make mistakes. And I just did one. So you can make mistakes. All right, so 10 minus 9 is 1. So my solution is 5 comma 1. So that's my solution. So in the blank, when it says solution, you would put 5 comma 1. Remember, ordered pair. So x has to go first and y has to go second. Now let's check it. Let's just check this. So you can check it like this. Always go back to the original. Always go back to the original. And my original had these 2 equations. So I'm just going to list them separately. And you can do this in your head, but I'm going to list them separately. So this is what you do in your head. And the other equation is this. All right, in place of x, what do I plug in? In place of y, what do I plug in? All right, so here we go. What's x? Plus 3 times y, what's y? And the question is that equal to an 8? Yes, that is 8. That's true. Because 5 plus 3 is 8. Go over here. Y equals, y is what? 1. And we see that's going to equal to 2 times x minus 9, right? So that's 10 minus 9, which is 1, and that's equal. All right, so 5, 1 is the solution. Okay, number 2. All right, let's look at this one. All right, listen carefully to this one. Suppose this was my system. 5x plus 2y equals 0. And x minus 3y equal 0. Okay, so step 1, I'm not going to rewrite it. Just go back to the previous page where you wrote the steps. Step 1 is to go to one of those equations and get the variable by itself. So take one of the equations and get the variable by itself. So which equation would you choose?
The one that has the one variable.
The one that has a coefficient of 1. So that's the only one I see. See, that's a 5, that's a 2, that's a -3, and that's a what? A 1. So step 1 is I'm going to pick which equation? X minus 3y equals 0, and I'm going to solve for what? Solve for x. All right, that's a 0 here, so that should be easy. That's to get x by itself, you're going to add 3y to both sides. So what does x equal? 3y. So that's your step 1. So x is going to equal what? 3y. Step 2 says I substitute that equation or that expression into the other equation. So in other words, see this expression here? So step 2, I'm going to substitute 3y into the other equation, right? So I'm going to take this right here, and the other equation is that first one. And where we see the variable what? X, because I'm saying x equal. So I already see the variable x, I'm going to plug in 3y. All right, so I get this. I get 5 times x, and what's x? 3y plus 2 what? Y equal 0. Okay? So 5 times 3y is 15y plus 2y equals 0. What's this? So 17y equals 0, and I divide both sides by 17. What is y? 0. So y is 0. So my solution so far, as an ordered pair, where do I put this 0? On the second coordinate, because that's my y. Now I've got to solve for what? X. Now this right here was step 2. This, remember, was step 3, right? Step 3 was where you did what? Solve. Okay, step 4 is where you're going to do what? Back substitute. So in other words, I'm going to substitute y equals 0 into, and always go back to the one that's in step 1. So remember, I got to solve for, the whole idea here is to solve for what variable? Solve for x. I got to find x, right? I got to find x. So I'm going to go to which equation? And one in step 1, because that's what x is. So I'm going to say into x equal 3y. So I'm going to say x equals 3 times y. What's y? So what's my answer?
0.
So what's my solution?
0,
0, 0. So 0, 0 is the origin, right? All right, let's check it. That you can do easily. What?
So, yep, well, I got lost right there. Okay, so the substitute is y 0. You plug that back into,
Step 1.
right.
I'm solving for x.
equation. The first one and the second one we started out with.
Well, he isolated it.
And it really didn't matter. If I go to either one of those and I plug in 0 into x, can I easily solve for y?
Yeah.
Yeah.
But that was just
But here, step 1, you already had the variable by itself. So just go there. Now, that's assuming you did this correctly, right? So that's why you need to always check. So always go back and check into the original. What's 5 times 0? What's 2 times 0? What's 0 plus 0? Okay, that's what you wanted. What's x? What's 3 times 0? What's 0 minus 0? So that works. All right, let's look at another one. We'll do one more with substitution, and then we're going to do the addition method. Okay, so let's look at this one. All right, this is going to be number 3. Number 3, substitution. Okay. X minus 4y equals a negative 2. X minus 6y equal 8. All right. Step 1. Yeah, which equation do you want to choose? Did it matter? No. Either one. If I choose this one, it's easy to get what variable by itself? X. If I choose this one, it's also easy to get what variable by itself? X. So I'm just going to go ahead and use the first one. So I'm going to pick the first one. And then solve for what letter? What variable? All right. So to do that, I'm going to add 4y to both sides. Right? That's a 4y. Combine like terms. I get x to equal 4y minus 2. All right. So there's my x. So that's step 1. All right. Step 2. We're going to substitute this expression here, 4y minus 2, into the other equation. So the other equation being the first or the second? The second. So basically just underline this and then go here, and wherever I see which variable, x, because that's what x equals, right? So I already see the variable x, I'm going to plug in 4y minus 2. And we go back to the other equation. So here's x. What am I saying x equals?
4y minus 2.
And then I'm going to say minus what? And that's going to equal what? 8. All right, so that was your step 2. So it kind of makes sense because this right here is what? Is x, and x minus 6y equals 8, which is what this is. So always look back to this. Make sure it makes sense. Step 3 is to solve. All right, combine like terms. What's 4y and a negative 6y?
Negative 2y.
And then equal 8. What's the next step?
Add 2.
Yep. Negative 2y what? Okay. What's the next step?
Negative 2.
So y is negative 5. You all agree? So far I've found the y coordinate of my solution. So what goes here? Now we've got to find what? X. So that will be step 4. Okay, so I'm going to substitute y equal negative 5. Now, really, you're supposed to go back to one of the original equations, because this, you could see how some of you probably would have said this is too wide, because some, I don't know why, but at your level, you shouldn't be doing that anymore. Negative 2 plus 4y is not 2y, because those are not like terms. So it's just 4y what? Minus 2. So someone else could have missed this right here. So really, you're supposed to go back to one of these. But assuming this is correct, it's okay for you to substitute y equal negative 5 into the equation that is in step 1. So I'm going to substitute y equals negative 5 into x equal 4y minus 2. That's the equation that's in what? Step 1. Because remember, you're solving for x. You're solving for x, and that's what this is. So wherever you see a y, what do I plug in? Negative 5. So wherever you see a y, you're going to plug in negative 5. So I get x equal 4 times y. What's y? Minus 2. What's 4 times negative 5? And so what's the answer? Negative 22. So my solution is negative 22, comma, negative 5. Negative 22, comma, negative 5. And you can check it. It's always a good idea to check if you have time. I'm going to rewrite the equations. Remember, when checking, always go back to the original equations. I'll go back to those. So if you check this, so wherever C and X would I'll plug in, and wherever C and Y would I'll plug in. All right, so I get negative 22, subtract 4 times A, negative 5, and I want to see if that's going to equal the other side, which is A, negative 2. So that's negative 22. What's a negative 4 times a negative 5?
Positive 20.
And tell me what this is, which is what I wanted. So that's okay. Over here, what's X? Subtract 6 times Y. What's Y? And again, I want to see if that's going to equal 8 this time. So I got negative 22. What's a negative 5 times a negative 6? Positive 30. And what's negative 22 and a 30? 8. And that's what you wanted. So that's correct. Negative 22, comma, negative 5. Okay?
Do you want us to show that checking on?
No, I'm not going to ask you to check, but on a worksheet you have time to check. So if you said this was negative 22, 0, obviously it's wrong, right? And then I'll say on your, I'm not going to take off if you don't check, but I would say you should have checked. All right? All right. You have time to check on a worksheet.
Break time?
No. Okay, so that's the end of substitution. So we can go. It's 5 minutes now, right?
Yeah.
So 5 minutes for